Good morning, everyone. I hope you're enjoying your sessions today. I am Kevin Sullivan. I'm the Enterprise Network Architecture Lead for Comstor. I'm your host for this session. Before we kick off, just a little bit of housekeeping. You will see that your microphones are muted. So if you have any questions during the session, please put them in the Q&A panel on the right. We will endeavour to answer these at the end of the session. If we can't, then I will follow up after the event. Anyway, let's get on with the show. It is my pleasure to introduce Adam Wilson, a distinguished systems engineer from Cisco. He will provide us with the latest insights and demos about network analytics and how they can improve business and operational efficiencies for businesses of all sizes. So please join me in inviting Adam to the virtual stage. Over to you, Adam.
Thank you very much, Kevin. Good morning and welcome, and thanks for spending some time with us this morning. I wanted to talk a little bit today about network analytics and assurance. And one of the reasons for talking about this is, as a network engineer, I've noticed over the last couple of years that I've had a dramatic increase in the number of invites from my friends and colleagues to come around to their place for dinner. And it took me a little while to catch on to why they were doing this, but basically implicit in any of those invitations was an invitation to also troubleshoot their home broadband or wireless network. And one of the challenges I think that we've seen with the rise of networking and connectivity is that as it becomes increasingly important, it also becomes really important that we're able to troubleshoot and understand how well that network is performing. And one of the challenges that I see with this is that as a network engineer, often what happens is the first thing that users say if an application isn't performing is that it's the network's fault. And the challenge with that is that the networking team then has to spend a lot of time working out whether the network is or isn't to blame. And one of my customers has a metric that they measure now, which is called mean time to innocence. So how quickly can they prove that it's not the network's fault? And if it is the network's fault, then how quickly can they resolve it? And I think one of the challenges is that we as networking vendors haven't necessarily given you as customers and partners the necessary tools to effectively root cause and troubleshoot networking challenges. One of the other challenges I see as a network engineer and with networking in general is that it tends to be taken for granted. It's a little bit like air and water. Without it, you can't survive, but people don't realize how important it is until it's gone. And I always think about a network engineer as being a little bit like an umpire or a referee at a sporting game. If you're doing a great job, you're invisible and nobody knows that you're there. And everybody assumes that you're off to the beach and relaxing somewhere. But the moment that a network issue occurs, then all of the focus is on you. So one of the challenges as a network engineer and working with the business is, how do you prove that you're doing a good job? Because if you're really doing a good job, then the network is working perfectly. There are no tickets that are open, so people assume that you're not doing anything. And one of the things that I've seen is that we haven't necessarily had a good way of articulating how well the network is performing. Sure, people have rather naive metrics that they look at, like how many megabits per second I'm getting or how many gigabytes of data are being sent through the network, but they're not necessarily an indication of experience. They're more an indication of the net throughput of applications on the network. It doesn't necessarily mean that they're performing as they should. So we set about trying to address this challenge, and one of the things that we did was we looked at how we could collect all of the possible pieces of network telemetry that existed. Because as a network engineer, if you're troubleshooting a network or if someone is trying to troubleshoot a network for you, there is no shortage of data. It's just that the data is in lots of different places and needs to be correlated and aggregated. So we set about trying through this concept of assurance, trying to collect, aggregate, and correlate all of this data to give you an understanding of how well the network is performing. So this concept is called health, And essentially what we've been doing is looking across all of the network infrastructure, not just wireless, but wired. We know that roughly 50% of the issues that occur with networking occur in the WAN, so looking at WAN connectivity and WAN performance, and then tying all that together into this concept of health. Now, what we did was we looked at it from two different perspectives, because as a network engineer, I care deeply about network devices. I care about their memory, their CPU, how are they feeling, how are they performing. But that is really important in terms of how I do my job. But of course, you as consumers or users of the network really don't care about those devices. You don't care at all, right? What you care about is, as a user, how quickly am I getting onto the network? And then once I am on the network, what's my experience like? So that's why we've looked at this in two different lenses. We've looked at it from the lens of a network engineer, which is the network device health. And we've also looked at it from the user side, which is the client or user health. And obviously there's some other unique aspects of this, because if you think about the difference between wired and wireless, wireless is highly variable. I wave my hand, I change the RF characteristics of the room that I'm in at the moment. Wired tends to be quite binary. It either works or it doesn't. So we therefore looked at both of those slightly differently. So one of the things that we've been doing is focusing on this concept of health, and it's probably better to see this live. So if you look at what we show you the health of the network in terms of these views. You can see the network devices here. You can see the wired and wireless client health. We give you the issues that we've seen, and these issues can be collected from a bunch of different places. They can be from AI machine learning. They can be from heuristics that we have around how the network should perform. And of course, the next thing that you're going to want to know is, if this number is not perfect, or if this thing is red, how do I find out why? And the general approach here is that you either scroll down or drill down. So if I go down into client health, for example, I can scroll down and I can see that although most of my wireless clients are healthy, there's some that aren't. I've got this Sankey diagram. Again, I can get lots of metrics around how well the network is performing. I've got client onboarding times. I can see that both in real time as well as historically. I can drill down into these clients that are not potentially performing as well. I can see the list of the clients. I can even drill down into individual clients and find out information about each of those clients and how they're going. Now, the thing about this is that one of the other challenges that we've seen with troubleshooting these things is that it tends to be a lag between when the user reports an issue and when it actually occurred. And the obvious example is, it's Thursday today. I might run into someone and they'll tell me that they had a problem getting onto the network on Monday morning. Well, what do you expect me to do about it now? Well, the great thing about this is that this is almost like a black box flight recorder for the network. I can actually go back in time, and I can go back and see what was happening a couple of days ago, and I can see what the performance was, how well this client was connected. I can see where the client was connected, signal strength, signal to noise, all of the data that I would need to know about that particular point in time. I've got all of the events that occurred. I can see every attempt to authenticate and get onto the network. Again, I can scroll down. I can see all of the events in detail. I've got access to all of this information. I've got detailed information about the connectivity. I've got information about the RF characteristics. I've got everything that I want to know about this particular client at any point in time over the last couple of weeks. So really, really powerful, really useful concept. And the fact that we've also aggregated and summarized this makes it really easy for people to understand how well a network is performing. The other thing that we have been working on is trying to get access to more information. So, some information is good, more information is better. One of the other things that we've done is we've been looking at turning everything into the network into a sensor. And one of the good examples of that is what we've done with the access points. So inside our access points, we've got this concept of intelligent capture. And you could think about it a little bit like the way that a security video works. So it loops on a tape, and over an hour or 2 hours, that tape will be rewritten. So what the access points are doing in the background and not impacting performance is that they are recording the protocol data of the wireless connections that are being made. And the nice thing about that is that if I determine that there was an issue, I can actually retrospectively grab the history and make that available. So this concept of intelligent capture is really useful because it means that I don't have to send someone out to site to try and troubleshoot a problem. I can do that remotely. And that's something that the access points themselves have built in. There's some ASIC technology that we've built into that. And again, it probably makes sense to see how that works. So if I look at this concept of intelligent capture, what I can do is I can do this proactively. And this is the example of the VIP user. So what I can do is, a user is having a problem, I can set this intelligent capture running, and essentially it doesn't matter which access point they connect to in the network, it's going to remember where they are, and it's going to capture the metadata around their connection. Now, in this mode, it's just catching the metadata around the connection, so the protocol pieces, because that's really what you care about in terms of troubleshooting. Some of the access points also have the ability to do a full packet capture, so it will capture absolutely everything. But in terms of the intelligent capture, often what you're looking for is protocol issues connecting to the network, and you can set that up very easily here. So I can have a bunch of these running at a time. If I click down into one that I have already, what you'll see here is that it takes me to the Client 360, which is the thing that I showed you before, but this is a special view that shows you the intelligent capture piece. You can see that the capture is running live at the moment. And what it's going to show me is it's going to show me all of the events that have occurred. And you notice that there's a little PCAP here. And I can click down into this, and what it's going to show me is it's going to do an intelligent decode, and it's also going to allow me to download those packets. So it's giving me a decode of what it saw, and it's allowing me to download those packets as a PCAP file, and then I could further analyze that if I wanted to. But you can see that everything that's been going on here has been recorded, and these files are automatically being uploaded, so I have access to those at a later point in time. The next thing that I wanted to talk about was AI/ML, and no presentation would be complete without touching on probably the biggest buzzword on the planet at the moment. And I just wanted to give you an insight into some of the things that we've been doing around this. The challenge, I think, with AI/ML is that it's a little bit like fairy dust. Everybody sprinkles it on whatever technology they're selling and claim that it's going to solve every problem known to personkind. The reality with AI/ML is that there are some really good problems that it's very well suited to. So one of those problems happens to be detecting deviations or anomalies. And if you think about the way that we've traditionally done network management, we've often used static thresholds as being the way that we determine whether the network is working correctly. Now, the issue with that is that if I have that threshold too low, then I get too many events and I tend to ignore them. And I'm sure many of you have network management systems that you just ignore because they send you all of this stuff that you really don't care about because it doesn't make sense. The other challenge is if I set the threshold too high, then obviously I miss things that I may care about. So one of the big opportunities around AI/ML is determining what normal behavior is. And a lot of what we've been doing, at least in the early parts of this, has been exactly that. So if you look at the way that we generate issues, we're able to proactively generate issues based on things that we know about. So for example, a sensor failing a DHCP test, that's an issue that we know about. You don't need AI/ML to tell you that. That's a pretty simple thing to do. But something like excessive time to connect or high deviation from the baseline is something that is a little bit more useful. So if I drill down into this, you can see that this has occurred a couple of times. The first thing that I'm doing is I'm also giving you the impact of this event. So I'm telling you that in this particular occasion, there was 1,700 clients that were impacted. So that's probably something that I care about. You'll also notice that it might appear as though these names are meaningless. And the reason for that is that this is actually real data from a customer. And what we've been doing is we've been given access to that, but because the data is encrypted the moment that it leaves DNAC, we have the ability to use this in the cloud, and it's completely secure. So there's no privacy issues. So essentially what I'm able to do here is I'm able to click down into this. I'm able to see what normal behavior should be, which is this green band. And then the blue line represents what's actually happened. And you can see where there's a deviation from that. You can see that we've flagged an anomaly. Now, we give you the impact that I showed you earlier. We can show you the clients and the access points and where they are. We can also give you what's called a root cause analysis, which, based on all of the KPIs that we're measuring, does a correlation between other things that occurred at the same point in time and the event. Now, just because there's a correlation doesn't mean there's causation. So we will have some ideas around what is likely to cause it. You can also vote up and down. But this is a really powerful thing in terms of giving you access to data, highlighting these anomalies, and then, of course, providing some suggested action. So there's a lot that we've been doing here. This is just touching the surface. And essentially, the key thing that I wanted to make sure that you're aware of is that the data is encrypted before it goes out. Obviously, if it's a cloud-based service for machine learning, it needs to be a cloud-based service because you need to have large data sets that you're applying models across. But the data is anonymized at the moment that it leaves your location. So in terms of takeaways, because I know that we're starting to run out of time, obviously we've been providing an integrated view of wired and wireless, both across the campus and the WAN. We're thinking about everything as a sensor. I didn't touch on this, but things like iOS devices, Apple is a partnership that we have where they give us special metadata. We've just extended that to Samsung. So we're able to get data from the clients themselves, and that's something unique that we have. Obviously, we have a fair amount of experience with networking in terms of the data sets that we have around what normal behavior is, what anomalies are. And there's a lot of work that we've been doing around AI/ML in the background to tie that together. And I think it's also worth pointing out that it's not just around the network that we have access to this capability. You would have heard Vanessa talk about what we're doing in the cloud space. Obviously, we're doing work in the wireless LAN, wired, and WAN space. The data center team is doing a bunch of different things, as well as all of the work that we're doing around security, around being proactive in terms of detecting events in security. So I think that's all that I had time for. I know we're going to have some questions now, but yeah, thank you very much for your time. Hope you found this useful, and let's open it up for some questions. Over to you, Kevin.
Thank you, Adam. That was absolutely awesome. Some great insight. Yes, we've got a few questions that come in. The first question I'll put to you is, a lot of people already have prime infrastructure to manage their wireless and everything else. Can they get this capability, or are they best to migrate towards DNA Center?
Yeah, so a lot of this capability is specific to DNA Center. With DNA Center, we tried to reinvent network management from the ground up. And a lot of the things that you've seen here won't be in prime infrastructure. And obviously the plan is to move the things that make sense for prime infrastructure into DNA Center. And we're pretty close to getting there.
Right. Another question that came in. So when you were talking about the AI intelligence side of things, can that be done also across the Meraki gear?
Yeah, so Meraki has some AI that they're doing as well. So they have some insights that they're generating. In DNA Center, we're starting some integration between Meraki and DNAC. That will continue. So that's going to continue, but they do have AI ML, yes.
Excellent. And another question just come in. How can we access DNA Center training so that we can move down this path or this roadmap?
Yep. So there's a bunch of training courses that we have. I think it's probably best to talk to your local Cisco person to get access to those. There are partners that provide training, so there's a couple of different avenues that we have for training.
Well, I think that's probably about it at this stage. We have a keynote coming up. I would first like to thank Adam for coming along and giving us his insights and showing us the demo. I hope everybody found it as interesting as I did, and I appreciate your attendance. So, yes, thank you very much for your time.
Thank you, and have a great day. Enjoy the rest of the event.